Hello everyone and welcome to this presentation. Today we're going to solve some examples on level curves and describe some level services. So first of all, we're going to start with the first example, example A. So example A says that f of x y equals the square root of x minus 2y squared. So we want to draw some level curves, and we know that if we want to draw any level curves, we need to set f of xy equals to c and substitute some values for c. For it could be 0, 1, negative 1, and etc. So we're gonna now set f of x equals to c. So we're gonna have x minus 2y squared. Now let's take c equals to 0. So 0 equals square root of x minus 2y squared, which gives us, if we square both sides, we're going to have 0 equals x minus 2y squared, which implies that 2y squared equals to x, and y equals to square root of x times 1 over square root 2. So this is basically the square root function, and if we have c equals to 1, we can say 1 equals square root of x minus 2y squared, which gives us 1 equals x minus 2y squared, which then gives us basically 2y squared equals x minus 1, y squared equals x minus 1 over 2, and then this is basically y equals 1 over root 2 times square root of x minus 1. So this is also the same square root, but it's gonna be, as we're gonna see now, it's gonna be transferred like 1 unit to the right, or yeah, so it's gonna be transferred 1 unit to the right. This is our first example, example 1. Okay, so let's take c equals to minus 1. So minus 1 equals the square root of x minus 2y squared. This is gonna give us 1 equals x minus 2y squared, which is basically will yield us at the end y equals square root of 2 root of x minus 1. If we want to take c equals 2, we're gonna take some values here. So square root of x minus 2y squared is gonna give us 4 equals x minus 2y squared, which is gonna yield 2y squared equals x minus 4, and so y equals square root of 2 square root of x minus 4. Now if we want to draw this, we're gonna draw here the y-axis, and also we're gonna have the x-axis, so xy, and then we're gonna start drawing the first curve. So the first curve is basically this one, y equals 1 over root 2 square root of x. So the square root of x is it's basically this. Okay, so let's say that this is 1 over root 2 square root of x, and it goes like this. And then we're gonna have the second level curve is y equals 1 over square root of 2 x minus 1. So we're gonna here have 1, and we're gonna basically draw the same curve like this. Of course, the square root cannot be negative, so and we can say that instead of this, we can say this is for c equals 0, this is for c equals 1, or c equals negative 1. These are the same curves. And basically, what does this mean? This means that if we intersect the graph the graph that we have, if we intersected with at the point C, if we intersect the graph in the xy plane and letting C equal to 0, okay, or intersected at z equals 0, okay, if we have the height, then we're gonna have this intersection, which is basically the square root function multiplied by a constant. And if we intersect the function at c equals 1 or c equals -1, we're gonna get this curve. And if we intersect at c equals 2, we're gonna get the other curve, which is basically, if you go here and say this is 2, 3, and 4, we're gonna start from here and we're gonna go like that. And this is our curve when we intersect at c equals 2. And I think c equals -2 is gonna be the same, so this is our level curves. So assume these are square root functions and these are our level curves. So we drew some level curves as required. Now we can go to example B. The function is f of xy square root of 1 minus x squared minus 5y squared. Now for level curves, we need to let c equals f of xy. And so c will equal to 1 minus x squared minus 5y squared. And if we let c equals 0, we're gonna have 0 equals square root of 1 minus x squared minus 5y squared, which is gonna give us 0 equals square root of 1, without the square root, we're gonna square now. We're gonna square both sides, so 1 minus x squared minus 5y squared, okay. So we're gonna have 5y squared equals 1 minus x squared, which gonna give us basically, this looks like a parabola. Y equals 1 minus x squared over 5. I'm gonna take the square root of this. Let's see what we get from this graph. So this is 5y squared equals 1 minus x squared. So let's go to Dismas and draw this graph. Let's see what we get. I think it's a parabola. So Dismas graphing calculator, gonna have y equal to square root divided by 1 minus x squared all over 5. Okay, so actually this is this looks like an ellipse. Okay, so this is an ellipse. If we square this, yes, this is okay. So this is an ellipse. So okay, I should have known that. This really looks like an ellipse. Yes, that's correct. Yes, it does look like an ellipse. And so since we have 5y squared plus x squared equals 1, if you have y squared plus x squared equals 1, this is gonna be a circle. But since we have here a coefficient which is 5, then this is gonna be an ellipse. Okay, so this is an ellipse basically, which is not very hard to draw. So let's just leave it like that. Now let's take c equals to 1. It should give us also an ellipse, possibly with a different radius. X squared minus 5y squared. Let's check and see if it will give us an ellipse or not. 1 minus x squared minus 5y squared. Okay, this could not be an ellipse now. This will become x squared plus 5y squared equal to 0, which gives us y squared equals x squared over 5, or minus taking square root of both. Okay, we cannot do that. We cannot take square root of minus, and x squared is always positive. So in this case, let's try to graph this. Let's graph this function and see what we get. X squared plus 5y squared equals 0. X squared plus 5y squared should equal to 0. Let's press enter. See what we get. Okay, so there is no such a function apparently, and yes, because it's so basically what is this saying is saying that this is an ellipse with radius 0, and we cannot have an ellipse with radius 0, and for that we are not gonna have a graph at c equals 0, so no graph or no curve, let's say. Okay, at c equals 1, and then c equals -1. Let's try that now. It's gonna give us the same. 1 equals 1 minus x squared minus 5y squared, which is gonna give us basically the same thing. And we say that we do not have a curve at c, no curve at c equals -1. Let's take now c equals to 2. This should give us something. 1 minus x squared minus 5y squared yields 4 equals 1 minus x squared minus 5y squared. And then if we go like this, we're gonna have 3 equals negative x squared minus 5y squared, or minus 3 equals x squared minus plus 5y squared. Let's see what this gives us. So okay, here we have this. Let's just replace this with -3. Okay, it gives us nothing. It gives us nothing. Yep. So we do not have a function as such function also. So at c equals 1, we do not have a function too. Can we just check our function? Did we copy it right? Yes, we did copy it right. And apparently some values do not have an intersection or a curve when stylized at that specific value. So now we would try to have c values that give us positive values. So for instance, I would try to do something like okay, so let me try doing something like taking the square root or taking a fraction, like let's say 1/4 or 1/2. Let's take c equals 1/2. So if we say 1/2 equals the square root of 1 minus x squared minus 5y squared, now if we square 1/2, we're gonna get 1/4 equals 1 minus x squared minus 5y squared, which basically gives us 1 over 4 equals 1 over 2. So this is negative 3 over 4 equals minus x squared minus 5y squared. And what is this basically? This is x squared plus 5y squared equals 3 over 4. And this is an ellipse. This is for sure an ellipse with radius is not gonna be 3 over 4, it's gonna be square root of 3 over 4 if I'm not wrong. 3 over 4. Okay, see, now this value 0.66. 3 over 4 is not 0.66. 3 over 4 is 0.75. Okay, so as you can see, this is the intersection that I'm looking at. The intersection with the x-axis is 0.8. So for our first example, when we had the radius equals to 1, we have the intersection equals to 1. Here the intersection is at the square root of 3 over 4. So the radius is basically the square root of 3 over 4. And if we go to a calculator now, let's go, for example, do square root of 3 over 4. This is gonna give us 0.866, which is basically this value. So this is an ellipse with radius square root, or square root of 3 over 4, written as 3 square root of 3 over 2. So this is the radius, which is approximately equal to 0.866. Exactly like that. Now, if we want to take also other values, we can, but let's just stick with this. Let's draw now our x-axis and xy-axis coordinates, and then let's say first we want to draw our ellipse. So let's just check the intersections. So here we said the intersection is 1, but here up it's 0 and 0.447. Okay, I think if we substitute, if we let y equal to, or x equal to 0, we're gonna get the square root of 1 over 5. So the intersection here is the square root of 1 over 5, which is 0.44. So let's write it in this form, 0.44. So now let's have here 1, let's have here negative 1, here 0.45, negative 0.45, and now this is our first level curve, which is at c equal to 0. And then let's have our second level curve, which is at around here. Okay, which is at c equals to 1 over 2. Let's draw an arrow. And if we want to do more, we can just basically say substitute c equals 1 over 3, for instance. c 1 over 3 will produce 1 over 3 minus 1, will give us basically 1 over 3, 2 over 3, 2 over 3. Okay, so we're gonna have the square root of 2 over 3. What is the value of the square root of 2 over 3? You know, we can just stick with this. We can, if you want, we can draw curves like this, and these should represent the other level curves. Okay, so these are our level curves. So if we intersect now the graph at c equals 0, we're gonna get the outer curve. If we intersect it at c equals 1 over 2, we're gonna get the inner curve. If we go even smaller numbers of c, we're gonna go for 1 over 3, 1 over 4, 1 over 5. We're gonna get the very innermost curves here, which are all ellipses. So this is our second example. Now going to our last example here, which is C. It involves 3 variables. So C. So f of x, y, z is gonna equal to, okay, 1 over square root of 4 minus 2x minus y minus z, minus y minus z. This is our curve. Now we're gonna let C equals f of x, y, z, and which is gonna equal our function, and we're gonna substitute some values. Try to substitute some values here. So for instance, C equals 0. Let's say now 0 equals to 1 over square root of 4 minus 2x minus y minus z. Okay. And if you want to draw this, this is gonna be a surface actually. Should be a surface. Oh no. Oh. So, okay, so now for 0, we cannot get this to give us a value of 0. Okay, since here the numerator is 1, so no level curves. Okay. Since if we want to get 0 here, okay, we need to get 0 in the numerator, and this is impossible. We cannot get value of 0 in the numerator. It's only 1. So there are no level curves for C equals 0. Now let's get another value. So C equals 1. 1 equals 1 over 4 minus 2x minus y minus z. Now let's have 1 equals square root of 4 minus 2x minus y minus z, which is basically 1 equals 4 minus 2x minus y minus z, or 2x plus y plus z equal to 3. Now if we want to sketch this surface, it's not gonna be very easy to do. So C equals -1. So we may do it with a graphing calculator, which makes things easier for us. So -1 equals 1 over square root of 4 minus 2x minus y minus z. Now -4 minus 2x minus y minus z equal to 1. You're gonna square and then get the same exact answer as C equals to 1. So we're gonna get 2x plus y plus z equal to 3. Now let's try another value. C equals 2. 2 equal to 1 over square root of 4 minus 2x minus y minus z, which is gonna give us 4 minus 2x minus y minus z equal to 1 over square root of 2. Or sorry, 1 over 4, because we're gonna move this way and then get 1 over 2 here. Square that, we're gonna get 1 over 4, and then get 2x plus y plus z equal to 4 minus 1 over 4. So 16 over 4 minus 1 over 4 equals 15 over 4. Now let's try to sketch this on Desmos. It's gonna allow us to sketch three variables or surface. See, it's gonna allow us to do that in here. So this is our first level curve. 2x plus y plus z. Equal to 4 or 3. Okay, so it's not gonna allow us to draw it here. Let's try the 3D calculator for Desmos. 3D graphing calculator. Now here we can do it. 2x plus y plus z equal to 3. Now this is our surface for c equals to 0, as you can see it. Sorry, for c equals to 1, we said 0. C equals to 0 has no level curve. Now let's try c equals to 2. So 2x plus y plus z equals 15 over 4. Okay. So this is our surface, as you can see. It is an oblique shaped surface, and it intersects with the x and y and z planes. Now let's have 2x plus y plus z. This is for c equals 2. So c 15 over 3. Okay, so now this is the second level curve, and if you continue, we're gonna draw also other curves to the left of them, and as you can see, they are all parallel. So these are 2 level curves, and also we can draw more of these if we tried using more values. So as you can see, these are the level curves. And that's all. Thank you everyone for watching. We covered now the level curves of surfaces.